Section 2, Introducing DevOps. In the cloud, your application is not just your application. Your application includes the infrastructure required to run it. This infrastructure can include virtual private clouds or VPCs, elastic load balancing, auto-scaling groups, Amazon Relational Database Service or Amazon RDS databases, Amazon Simple Storage Service or Amazon S3 buckets and their associated data, Amazon Elasticache servers, and any other AWS and non-AWS resources that your application requires to run. This way of thinking might be different than what some developers are used to. Until the past 20 years or so, software development, or dev teams, and systems operations, also known as SysOps teams, often worked independently. Developers would ensure that applications worked in their dev environments, but they would leave it up to the systems administrators to set up the corresponding production environment. This disconnected approach would result in expensive, time-consuming conversations between the two teams, as SysOps teams would often struggle to host applications created by the dev teams on a scalable, secure infrastructure. The advent of cloud technology has changed that dynamic. Cloud technology gives developers the ability to provision their own infrastructure, test their code on that infrastructure at scale, and turn that infrastructure off when not in use. With this flexibility, developers can even create environments that are similar or identical to the environments their applications run in when deployed to production. Thanks to these technological advances, new ways of thinking about software development have emerged. These advances have fostered new software development methodologies, such as Agile, DevOps, and DevSecOps. DevOps, which is a combination of development and operations, is a combination of cultural philosophies, practices, and tools. DevSecOps takes this combination one step further by integrating security into the DevOps philosophy. One motto commonly used in DevOps culture is people over process over tools. DevOps is more a mentality than a specific set of tools. It's about removing the barrier between development and operations teams and getting them to communicate with each other. Using DevOps, teams optimize both the productivity of developers and the reliability of operations by working together. DevOps supports a set of practices that leads to rapid delivery of secure, reliable, and maintainable software. Those practices include microservice architecture, continuous integration and continuous delivery, automation, and infrastructure as code. We'll take a closer look at each of these practices. We'll start with microservice architecture. Instead of a monolithic application in which all processes are tightly coupled and run as a single service, you can write your applications as discrete microservices that run independently inside containers or as AWS functions. This leads to code that is more maintainable and scalable because you can add, remove, or update individual application components as new features and updates are needed, rather than rewrite an entire codebase. The next practice is CI/CD. Continuous integration, or CI, is software development practice in which developers regularly merge their code changes into a central repository. Continuous deployment, also referred to as CD, is a software development practice where code changes are automatically built, tested, and prepared for production release. CD expands on CI by deploying all code changes to a testing environment, production environment, or both after the build stage is complete. When CD is properly implemented, developers always have a deployment-ready build artifact that has passed through a standardized test process. Code that has been deployed requires continuous monitoring and improvement. You'll learn more about CI/CD later in this module. Automation is the third practice on our list. DevOps supports the practice of automating every phase of the software development lifecycle. Automation reduces the level of human effort required in each phase and reduces errors caused by manual processes. This automation from beginning to end is an element of continuous deployment. Last on our list is infrastructure as code. You can use CloudFormation to create a repeatable method to deploy your cloud architecture, which we'll cover more in depth later in this module. Adopting DevOps provides you with a number of benefits. Under DevOps, development and operations are no longer separate functions. They are often merged under a single team of engineers working together across the entire software development lifecycle. DevOps practices will result in code that is secure, reliable, and maintainable. You can build automation to test for bugs and to monitor and audit changes to your environment. Releases are more reliable because you can automate the creation of development environments that mirror production environments. Using a microservices architecture for your applications makes code more maintainable and scalable because you can add, remove, and exchange individual application components as new features. This means only updates are needed instead of rewriting an entire code base. In turn, organizations that use DevOps can deliver value to their customers more quickly than organizations that use separate software development and infrastructure management processes. This speed means that businesses can scale to keep up with the pace of change and compete more effectively in the marketplace. As shown on this slide, AWS offers a range of services to help you provision and manage infrastructure, deploy application code, automate software release processes, and monitor application and infrastructure performance. In this module, you will learn about the AWS code services that support CI/CD, as well as the CloudFormation service. Here are a few key takeaways from this section of the module. In the cloud, your application consists of the application plus all of the associated infrastructure. DevOps is about removing the barrier between development and operations teams and getting them to communicate with each other. DevOps practices result in code that is secure, reliable, and maintainable. Thanks for watching, and see you in the next video. For Section 3, using AWS code services for CI/CD. CI/CD is a DevOps practice that spans the develop, that is, code, build, and test, and deploy stages of the software development lifecycle, or SDLC. Continuous integration is the practice of continuously checking your code into a central code repository, for example, a Git repository or AWS code commit, and verifying each change with an automated build and test process. Developers previously worked in isolation for an extended period and only merged their code changes into the mainline, or parent, branch after their feature was completed. Batching changes made it difficult to merge the business logic and also the test logic. However, continuous integration practices have made teams more productive and allowed them to develop new features faster. Continuous integration requires teams to write automated tests that improve the quality of the software being released and reduce the time that it takes to validate that the new version of the software is good. Although there are different definitions of continuous integration, it is commonly thought that CI stops at the build stage. Continuous delivery extends continuous integration to include testing out to production-like stages and running verification testing against those deployments. Continuous delivery might extend all the way to production deployment, but some form of manual intervention occurs between when code is checked in and when that code is released to customers. Continuous delivery is a big step forward over continuous integration because it allows teams to gain a greater level of certainty that their software will work in production. Continuous deployment is the automated release of software to customers. This automation extends from check-in through production without human intervention. Continuous deployment reduces the time it takes to deliver business value, for example, new features or updates, to customers, and in turn, the time it takes to get customer feedback on those new releases. This fast customer feedback loop helps you to iterate and release valuable software updates quickly to customers. AWS code services can help you manage and automate your CI/CD pipeline. let's look at some of the code services AWS has to offer. AWS CodeStar is a cloud-based development service that enables you to quickly develop, build, and deploy applications on AWS. AWS CodeStar provides a unified user interface where you can manage your software development activities in one place. With AWS CodeStar, you can set up your entire continuous delivery toolchain in minutes, which helps you to release code faster. AWS CodeStar makes it easy for your whole team to work together securely, so you can easily manage access and add owners, contributors, and viewers to your projects. AWS Code Commit is a fully managed source control service that hosts secure, Git-based repositories. The service makes it easy for teams to collaborate on code in a secure and highly scalable ecosystem. Code Commit eliminates the need to operate your own source control system or worry about scaling its infrastructure. You can use Code Commit to securely store anything from source code to binaries, and it works seamlessly with your existing Git tools. AWS Code Build is a fully managed continuous integration service that compiles source code, runs tests, and produces software packages that are ready to deploy. With Code Build, you don't need to provision, manage, and scale your own build servers. Code Build scales continuously and processes multiple builds concurrently, so your builds are not left waiting in a queue. AWS Code Deploy is a fully managed deployment service that automates software deployments to a variety of compute services, such as Amazon Elastic Compute Cloud, or Amazon EC2, AWS Fargate, AWS Lambda, and your on-premises servers. Code Deploy makes it easier for you to rapidly release new features, helps you avoid downtime during application deployment, and handles the complexity of updating your applications. You can use Code Deploy to automate software deployments, which eliminates the need for error-prone manual operations. The service scales to match your deployment needs. AWS Code Pipeline is a fully managed continuous delivery service that helps you to automate your release pipelines for fast and reliable application and infrastructure updates. Code Pipeline automates the build, test, and deploy phases of your release process every time code changes, based on the release model that you define. This helps you to rapidly and reliably deliver features and updates. You can easily integrate Code Pipeline with third-party services, such as GitHub, or with your own custom plugin. Here are some of the key takeaways from this section of the module. CI/CD spans the develop and deploy stages of the software deployment lifecycle. It is commonly thought that continuous integration stops at the build stage. Continuous delivery improves on continuous integration by helping teams to gain a greater level of certainty that their software will work in production. Thanks for watching, and see you in the next video. Section 4, Deploying Applications with CloudFormation. As you've seen in this course, nearly everything that you can create in AWS through the AWS Management Console can be created programmatically by using an SDK or the AWS command line interface, commonly referred to as the AWS CLI. You can use this capability to define your infrastructure as a series of scripts or other code artifacts, which help you to create, update, and delete your AWS infrastructure automatically and in a repeatable fashion. You can also create multiple environments, development, testing, staging, and production from the same code base. This capability is referred to as infrastructure as code. What is CloudFormation and what can you use it for? CloudFormation is a fully managed service that provides a common language to describe and provision infrastructure resources in your cloud environment. CloudFormation creates, updates, and deletes the resources for your applications in environments called stacks. CloudFormation is all about automated resource provisioning. It simplifies the task of repeatedly and predictably creating groups of related resources that power your applications. Here we have an example of an application running on Amazon Elastic Compute Cloud or Amazon EC2 instances within a private subnet, the app subnet, behind a public subnet in a VPC. The application calls an Amazon RDS database and static assets in the form of an S3 bucket. Imagine the amount of time it would take to manually deploy and update these services. Automated provisioning with CloudFormation can help streamline the process. CloudFormation reads template files, which provide instructions for what resources need to be provisioned, and then constructs those resources. The output of this process is your environment or stack. A template can create a single resource stack or a stack with hundreds of resources. We'll look more closely at template files in a moment. Stacks are the resources generated by a template. A stack is also a unit of deployment. You can create stacks, update them by running a modified template, and delete them. When you delete a stack, all resources in the stack are deleted by default, although you can reconfigure or override this. When you author templates and create stacks, consider the default AWS quotas, formerly referred to as limits. This helps you avoid limitation errors that could require you to redesign your templates or stacks. If you need additional stacks beyond your quota, request an increase through the support center in the console. A CloudFormation template is a JSON or YAML formatted text file that describes your AWS infrastructure. If you provision your environment by using templates, they become a form of documentation for your environment. CloudFormation follows the ECMA JSON standard. The service also supports YAML version 1.1 specification with a few exceptions. CloudFormation does not support binary OMAP, pairs, set, timestamp tags, aliases, and hash merges. This slide contains an example of a CloudFormation template structure and its sections. Let's take a closer look. The Format Version section is the CloudFormation template version the template conforms to, which identifies the template's capabilities. The Description section is simply a text string that describes the template. The Metadata section contains objects that provide additional information about the template. The Parameters section contains values to pass to your template at runtime when you create or update a stack. The Mapping section is a mapping of keys and associated values, which you can use to specify conditional parameter values, similar to a lookup table. The Conditions section defines conditions that control whether certain resources are created or whether certain resource properties are assigned a value during stack creation or update. For example, you could conditionally create a resource that depends on whether the stack is for a production or test environment. The Transform section is used for serverless applications, those based on AWS Lambda, and specifies the version of AWS SAM to use. When you specify a transform, you can use AWS SAM syntax to declare resources in your template. The model defines the syntax to use and how it's processed. You'll learn about AWS SAM in another section of this module. The Resources section specifies the stack resources and their properties, such as an EC2 instance or S3 bucket. This is the only required section. Finally, the Output section describes the values returned whenever you view your stack's properties. You don't have to list your resources in the template in the exact order of creation. You can use the Depends On attribute to specify the order in which CloudFormation will create the resources. In this way, you can build a sequence of events, such as creating a database server before a web server. The highlighted portion of this slide is an example of a description section. This section contains a text string that describes the template. In this slide, we've highlighted an example of a parameters section. Parameters are values to pass to your template at runtime when you create or update a stack. Here we have an example of the resources section of a CloudFormation template. This is the only required section. It is used to specify the stack resources and their properties. This example describes an EC2 volume resource. Here are some of the key takeaways from this section. CloudFormation is a fully managed service that automates AWS resource provisioning. CloudFormation uses JSON or YAML formatted template files to provide resource provisioning instructions. A stack is a unit of deployment that you can create and update by using templates. When a stack is deleted, resources in the stack are also deleted. Thanks for watching, and we'll see you in the next video. Section 5. Deploying applications with AWS SAM. When working with serverless applications, you must provide everything needed to deploy a function: the code, any necessary dependencies, and the blueprint to set up the infrastructure. However, you can't create the environment locally. You don't connect to a specific server to debug code. You need the ability to deploy your stack to each AWS account. This is where an application framework such as AWS SAM is useful. The AWS Serverless Application Model, or AWS SAM, is an open source framework for building serverless applications. AWS SAM is an extension of CloudFormation, so you get the reliable deployment capabilities of CloudFormation. You can use AWS SAM to build templates that define your serverless applications. You then deploy your template with CloudFormation. AWS SAM has two components: the template specification and the CLI. Let's take a closer look at these components. The template specification defines your serverless application. It provides a shorthand syntax to describe the functions, APIs, permissions, configurations, and events that make up a serverless application. Use an AWS SAM template file to operate on a single deployable, versioned entity that is your serverless application. The CLI is a tool you can use to build serverless applications that are defined by AWS SAM templates. The CLI provides commands to verify that AWS SAM template files are written according to the specification. Commands are also available to invoke Lambda functions locally, debug Lambda functions, package and deploy serverless applications to the AWS cloud, and so on. AWS SAM has deep integration with CI/CD tools. You can use AWS SAM with code build, code deploy, and code pipeline to build a deployment pipeline for your serverless applications. You can also use AWS SAM with AWS CodeStar to get started with a project structure, code repository, and CI/CD pipeline that's automatically configured for you. AWS SAM provides an execution environment similar to Lambda, which is helpful for step-through and debugging of code. This can help you catch issues up front rather than later in the process. The AWS SAM template follows the CloudFormation template format, with some exceptions. Let's look at those exceptions. The transform declaration is required because it identifies the template as an AWS SAM template. The global section is unique to AWS SAM and is used to define properties common to all of your serverless functions and APIs. The resources section contains resources for both CloudFormation and AWS SAM. The parameters section is used to declare objects and present additional prompts to the user. Now, let's look more closely at the details of this example template. The transform declaration identifies the CloudFormation template file as an AWS SAM template file. In the resources section, AWS serverless function tells CloudFormation to create a Lambda function. The properties section references the .zip file, handler, and runtime to be used. The policy section provides the IAM policy to be referenced for the function. The template also includes commands to create an Amazon API gateway endpoint. The AWS SAM transform will perform the mappings and permissions. The last part of the template creates an Amazon DynamoDB table. Here are some of the key takeaways from this section. AWS SAM provides the capability to deploy your stack to each AWS account. As an extension of CloudFormation, AWS SAM provides the reliable deployment capabilities of CloudFormation. AWS SAM has deep integration with CI/CD tools like AWS Code Build, AWS Code Deploy, AWS Code Pipeline, and AWS CodeStar. Thanks for watching, and we'll see you in the next video.
Welcome to Module 14, Bridging to Certification. At the end of this module, you should be able to identify how to prepare for the AWS Certified Developer Associate exam and identify where to find resources. In this module, you will learn about AWS certification and the AWS Certified Developer Associate certification in particular, resources to help you achieve AWS certification, and resources to extend your learning. We'll begin with Section 1, Certification and Resources. AWS certification helps learners build credibility and confidence by validating their cloud expertise with an industry-recognized credential. Certification also helps organizations identify skilled professionals to lead cloud initiatives with AWS. Being AWS certified provides several benefits. First, you can showcase your AWS certification achievement with digital badges. Second, you get access to a 50% discount voucher to apply toward recertification or any other exam. Next, you receive invites to regional appreciation receptions, and you can use your digital badge to get exclusive access to AWS certification lounges at AWS reInvent and select AWS Summit events. You also gain access to the AWS certified community on LinkedIn, where you can network with your peers. You receive a practice exam voucher to help you prepare for your next AWS certification. And you unlock access to exclusive AWS certified merchandise. Domain 1 of the AWS Certified Developer Associate exam is deployment. It makes up 22% of the exam and covers 4 objectives. The first is deploy written code in AWS using existing continuous integration and continuous delivery, CI/CD, pipelines, processes, and patterns. The second is deploy applications using AWS Elastic Beanstalk. The third is prepare the application deployment package to be deployed to AWS. And the fourth is deploy serverless applications. Domain 2 is security. It makes up 26% of the exam and covers 3 objectives. Make authenticated calls to AWS services. Implement encryption using AWS services, and implement application authentication and authorization. Domain 3 is development with AWS services, and it makes up 30% of the exam. The first objective is write code for serverless applications. The second is translate functional requirements into application design. The third is implement application design into application code. And finally, the fourth is write code that interacts with AWS services by using APIs, SDKs, and the AWS command line interface, or AWS CLI. Domain 4 is refactoring, and it makes up 10% of the exam. The 2 objectives are optimize applications to best use AWS services and features, and migrate existing application code to run on AWS. Finally, Domain 5 is monitoring and troubleshooting. It makes up 12% of the exam. The first objective is write code that can be monitored, and the second is perform root cause analysis on faults found in testing or production. Several primary AWS resources are available to help you prepare for the exam and assess whether you are ready to take it. The exam guide describes the recommended knowledge for certification candidates, provides a content outline for each domain, and lists the tools, technologies, and concepts that might be on the exam. The sample exam questions are in the format that's used for the exam. The AWS Well-Architected website covers the 5 pillars of the Well-Architected framework and provides resources for learning about each one. With the AWS white papers and guides, you'll expand your knowledge of the cloud with AWS technical content authored by AWS and the AWS community. Resources include technical guides, reference material, and reference architecture diagrams. You can also browse through the FAQs to find